We're gonna do question 8. I just want to let you know that doing past papers from 2018 to 2021. So if you're watching this, go and watch other past papers because this is 2020. So go and watch other past papers to be equipped in this course. So we're having a graph of g of x being equals to ax cubed plus bx squared plus cx. A cubic function having a y-intercept of 0 is drawn below. The x coordinates of the turning points of g are -1 and 2. So we have everything in the graph, but sometimes the information is written and it's not presented in the graph, so always take note of that. So in this case, everything is written or is presented in the graph. So now let's just answer the question. So 8.1 says that for which values of x will g increase? So I mean, this is a point where the graph is increasing, right? This is a decreasing point and this is increasing point. So for which values of x? The only values of x we have, yes, this is 0, yes, this is -1, and this is 2, right? But it's still increasing here, so we don't have to start from this point. We can start from where it starts to increase and where it ends, so we can simply say when x lies between -1 and 2, so this would be the answer for the question, because it starts to increase from -1 all the way up to -2, but it's not really equals to, because the graph is 0 gradient there at -1 and 0 gradient at 2. So now going to 8.2, write down the x coordinate of the point of inflection of g. So the point of inflection lies just between here. We don't know where, but we know it's between the turning points, right? Here it's x equals to -1, here it's x equals to 2, right? So because we are not given the equation of g, we're going to use the information that we have. This, we know that this is symmetrical, right? So we can simply say x of the point of inflection is equals to -1, which is this x value, plus this x value of 2 divided by 2, right? And then we're gonna get 1/2. So x of p is 1/2. That is the x value of the point of inflection. So and then 8.3 says that for which values of x will g be concave down? So concave down just looks down, right? This is concave down, and this is concave up, so don't get confused. So we want to identify the values of x when this function is concave down. Concave down for this function is just this one, as you can see, it's this one here, concave down. So we are interpreting the value of x when that happens, when it becomes concave down. So remember that we said our x of p, point of inflection, is 1/2, right? Which lies somewhere here, I don't know where, but just let's say it's here, right? So where does the graph have concavity which is down, right? When x is greater than 1/2, right? When x is greater than 1/2, it starts to be concave down. When x is less than 1/2, it starts to be concave up. So when x is greater than 1/2 is the answer for this specific question. So let me erase here. So now 8.4 says that if g prime of x is equals to this, determine the equation of g. So remember that the equation of g is equals to, we're given is equals to ax cubed plus bx squared plus cx, right? So it's ax cubed plus bx squared plus cx, right? And we are given that the derivative of this g here is this, right? So let's derive this g. It's equals to we drop the 3, is going to be 3ax squared plus 2bx plus c, right? But we can see that the g prime of x is actually equals to minus 6x squared plus 6x plus 12. So what we can do is we can equate. We can say this portion here is actually equals to this. This portion here is equals to this, and this portion here is equals to this one here. So 3a is equals to 6, or let me rather say 2b is equals to 6, right? And then c is equals to 12. So this we done, this we just divide by 2 both sides, so b is equals to 3. This divide by 3, so this is negative, right? By the way, let me write it nicely. So it's going to be equals to negative 6. So divide by 3, our a value is equals to minus 2, our b value is equals to 3, our c value is equals to 12. So you can write our equation of g, right? Because that's what we're looking for. G of x equals to ax cubed plus bx squared plus cx, which is equals to minus 2x cubed plus 3x squared plus 12x. So this is the equation that they're looking for. We are done with this question here. So 8.5, determine the equation of the tangent to G that has a maximum gradient. Write down your answer in the form of, okay, fine. So what we need to first do here is we need to identify that gradient, right? We know very well that G prime of x is equals to, okay, G of x rather, let me just first write G of x. G of x we found in the previous question, right, to be minus 2x cubed plus 3x squared plus 12x. So the G prime of that is actually this value here. So it's just going to be minus 6x squared plus 6x plus 12, right? And what we know is that because we want to identify the equation of this tangent here, right, and we know the point of inflection is between the turning points, right, which is the 1/2 somewhere here. So the tangent can will touch this point of inflection, by the way. So we're just going to substitute that x value of 1/2 into this equation to find the actual gradient of this tangent, right? Plus 12, right? So once you substitute that 1/2 into this derivative, you get a gradient of 27/2. So that is the gradient of t, of the tangent. So now you have the gradient. Now you need to identify the 2 points. The first point of the tangent x of t is equals to 1/2. Now let's find the y value of the tangent. So we're going to substitute that y value. We're going to say x, g into x, which is equals to 1/2, is equals to what's the equation here? It's going to be minus 2 into 1/2 cubed plus 6 into 1/2 plus 12, right? So you should get your y value of 13/2. So this is the y value of the tangent. So now you have the gradient, you have the y value of the tangent, you know, everything is set. So what you will do is this. You will, let me just erase here. you're going to say y is equals to, y of t tangent is equals to mx plus c, right? Y of t is equals to the gradient, which is 27 over 2 x plus c, of which the point that we're substituting is this one, and 1 over 2. So x of t equals to 1 over 2. So where there's y, you're going to put 13 over 2 equals to 27 over 2 into 1 over 2 plus c. So we're just going to transpose this product here to the other side, and we should get, so let me remove this. We should get c being equals to minus 1 over 4, right? So that is the value of c, and y is equals to mx plus c. Y of t is equals to the gradient of 27 over 2x minus 1 over 4, right? So that is the equation of this tangent in this question. Thank you so much for watching. If you have any questions, suggestions, or comments, please write them in the comments section below. Don't forget to subscribe to the channel for more videos.